Hi everybody. Sorry I couldn't be in tutorial today, but I thought I would present this to you guys this way so you can at least see it being said. And then if you have any questions, I'll email out my hard copies and leave my phone on during tutorial so that you can call me, and I'll try and pick up wherever I am to give you a little explanation of what I meant. So, this week I researched hypoxic ischemic encephalopathy. And this is an asphyxia, which usually refers to an insult accompanied by decreased oxygen delivery to a fetal or neonatal brain. So in adults, the cerebral blood flow is maintained at constant levels throughout the day, despite a wide range in systemic blood pressure. And that's why we can, work out or get all excited or chill out, and it doesn't change what goes on in our brain. This phenomenon is known as cerebral autoregulation, and it's what kind of divides adults and children from the neonate and infants. Because in the human fetuses and newborn infants, the cerebral blood flow is much less stable. It's over a narrower range of blood pressures. So the blood pressure range at which the cerebral blood flow autoregulation is maintained for adults is about 40 millimeters of mercury, and for fetuses it's just 10 to 20. So in the fetus or newborn suffering from acute asphyxia, after those early compensatory mechanisms fail, they're really going to be dependent on passive pressure. So the perfusion of oxygen and blood in the brain is going to fully depend on the systemic blood pressure. And then as that blood pressure falls, cerebral blood flow falls below critical levels. And that's when the brain injury starts to occur secondary to the diminished blood supply and the lack of sufficient oxygen. Fortunately, during the early phases of brain injury, the brain temperature drops and a local release of neurotransmitters such as gamma-aminobutyric acid transaminase, or GABA, increase, and that's going to change the cerebral oxygen demand and minimize the impact of asphyxia, which is just sort of, a defense mechanism of the body to protect against that asphyxiation. Now during the reperfusion period, this gets a little complicated, so I'm going to try and simplify it as much as I can. Free radical production increases, and free radical damage is even worse in the neonate because the antioxidant defense mechanisms that the brain employs in the adult brains or more mature brains aren't yet present. So what happens is there's lipid peroxidation, which is when the lipids of the cell membranes oxidize and degrade. So all the cell membranes basically just disintegrate. Then DNA and protein damage occur and can trigger apoptosis. So I don't know if you remember from microbiology, but apoptosis is programmed cell death. It's less dangerous than necrosis because as the cell breaks up, and it allows pieces to be engulfed by the surrounding cells, and it can be a natural process. For instance, when fingers are formed in the fetal hand, it's the apoptosis that allows that wedge space to break up and form the fingers. Unfortunately, in this process, it's not natural and can be extremely dangerous. So following the initial phase of the energy failure from the asphyxial injury, the cerebral metabolism may recover following reperfusion, but it'll only deteriorate in a secondary energy failure phase. So the secondary phase is called the delayed phase of neuronal injury, and it's extremely dangerous. The duration is not precisely known, but it appears to increase over the first 24 to 48 hours and then starts to resolve thereafter. The duration of this phase is correlated with adverse neurodevelopmental outcomes at the 1 and 4 year marks after the insult. So the longer this lasts, the worse the long-term effects are going to be.